So we need to prove the following inequality by induction. So we need to prove that 4 to the power of n is greater than or equal to 3 to the power of n plus n squared for all n greater than or equal to 1. By method of principle of mathematical induction, the first step that we need to make, so step 1 is to substitute n equal 1 in the given equation. We do that to check if this inequality is true for the smallest value of n. So we know that n is greater or equal to 1, so the smallest value of n is 1, and for that value we will check our inequality. So we substitute n is equal to 1, and we get 4 to the power of 1 should be greater than or equal to 3 to the power of 1 plus 1 squared. And 4 to the power of 1 is 4, 3 to the power of 1 is 3, 1 squared is 1. So 4, on the left side we have 4, on the right side we have 4, so these two sides are equal. That means that inequality is true for n equal 1. Great, now we will do the next step, step 2. Here we will put n be equal some k. And we assume that for n equal k, this statement is true. So for n equal k, 4 to the power of k is greater than or equal to 3 to the power of k plus k squared. Now, knowing that for n equal k, this expression is true, we need to prove, so this is step 3, we need to prove that for n equal k plus 1, the expression 4 to the power of k plus 1 is greater than or equal to 3 to the power of k plus 1 plus k plus 1 squared is also true. Well, let's simplify this expression. So 4 to the power of k plus 1 needs to be greater than or equal to 3 to the power of k plus 1 plus k squared plus 2k plus 1. From the very beginning, we know that n needs to be greater than or equal to 1, so n is greater than or equal to 1, and that means that 4 to the power of k plus 1 is greater than or equal to 3 to the power of k plus 1 plus k squared plus 2k plus k. Great, so 2k plus k is just 3k, so we have 4 to the power of k plus 1 is greater or equal to 3 to the power of k plus 1 plus k squared plus 3k. And then from step 2, so from here, we know that 4 to the power of k minus 3 to the power of k is greater than or equal to k squared. And that means that 4 to the power of k plus 1 is greater than or equal to 3 to the power of k plus 1 plus 4 to the power of k minus 3k plus minus 3 to the power of k plus 3k. Well, again, we will simplify this. So 4 to the power of k plus 1 is greater or equal to 3 to the power of k times 3 minus 1 plus 4 to the power of k and plus 3k. So we have that 4 to the power of k plus 1 is greater than or equal to 2 times 3 to the power of k plus 4 to the power of k plus 3. So we get 4 to the power of k plus 1 is greater than or equal to 4 to the power of k plus 1. And we know that this is true, because 4 to the power of k plus 1 is equal to the power to 4 to the power of k plus 1. So that means that our initial expression, our initial statement is true. So we have just proved that really 4 to the power of n is greater than or equal to 3 to the power of n plus n squared by induction. So proved.